evening, guys. We are back with another problem, and today's problem is a problem on arrays. And today's problem is a bit higher on the medium level, so we can term this problem as a medium level problem. Medium level problem. And today's problem statement is basically on sorting. So this problem statement comes under the category of sorting of DSA, and also you can keep what type of sort we are going to use over here based on the time complexity and the efficiency of the program and the demand of the program. So we are going to use a quick sort algorithm over here. So people who always tell that, oh, we have predefined sorting techniques in Java, in Python, but all those techniques are not going to work when a problem statement like this comes. So in solving a problem statement like this, what you need to know is the specified sorting algorithms as well based on the time complexity. So the time complexity is basically of this is n log n. We go of n log n. Okay, we'll come to that later on. So first let us dive deep into the question and understand. So the question tells that there will be one screw. Okay, so say this is one screw and this is one bolt. Okay, so ignore the drawing. So this is a screw and this is a bolt. So screw can fit into a particular bolt if and only if the criteria are matched. Okay, so first we need to understand that we will be given an array of nuts and the array of bolts. A nut, so a nut will fit. So ignore this. Consider this is a nut. So nut will fit with a bolt if and only if the particular sorting sequence is matched. Okay. So before going to the question and diving deep into the question, let us take the examples and learn the question. So the best way we can learn DSA is by taking the examples and learning it. Okay. So first we are going to take the arrays as nuts arrays. So first, before doing that, we have to sort and return. We have to sort and return the array in the form of this particular order. Okay. So whatever our order is, we have to check over here. So we can create an order array. Okay. We can create an order array. So in the order array, we are going to put the variable. We are going to put the different elements. Okay. So first element is this exclamation mark. Then we have a hashtag. Then we have a dollar. Then we have a percentage. Then we have and symbol. Then we have a star, exponential star. Then we have a question mark. You can see these are various. You can see these are various symbols. These are the way you have to sort. So you can write it over here. You can write it over here. This is the sequence to be followed for sorting. Okay, this is the sequence we are going to follow for sorting. Now let's take the example. So we have the example as, say for example, nuts. So in the nuts array, I can take the particular example. So I will put it in this array class. Okay, so in the nuts array, what are the elements we can put? @ percentage dollar hashtag. So @ percentage dollar hashtag, and what we can put? A to the power symbol. Okay, and if you check the bolts array, we can check that the bolts array will have the following symbols. So in the bolts array, I'm going to put the symbols: percentage, @ percentage, @. So this is the @, and hashtag. Then we have a dollar symbol, and then we have an exponential symbol. So now let's check the output. The output has to be in order with this particular order array, which is given in the question. This is the order we have to maintain in order to make the matching of these nuts and bolts. So what you can see, as per the order, hashtag should come first, after the dollar, and then percentage, and then @. So these are the things. Okay. So what we are going to return? We are going to return hashtag, dollar, percentage. Then we are going to return @, and then to the power. So let's check. So the sequence is telling that first we have @ in the nuts array. So whenever we are sorting the @, you can see the sorting has to be done in such a way that this order is followed. So in this order, @ percentage dollar hashtag to the power, which one comes in the beginning? So definitely @ does not come in the beginning. And if we talk about percentage also does not come in the beginning. So what else is there? Hashtag comes in the beginning. Okay, so beginning, how you're checking the beginning is matching. We have to check this element with the order array. So if you see, hashtag comes in the first, in the sequence, in the priority list, hashtag is the top priority. So if you check the priority, then hashtag is the top priority. Okay, so over here you can, write it like this, that this is the top priority. Okay, top priority. After that, what you can see, after hashtag in the nuts array, we have to be focused with the nuts array. So in the nuts array, dollar is there. So is there anything more important than like dollar is there? So after at the rate percentage, then you can see percentage. So percentage, is there anything more important than percentage? Dollar. Yes. So we have taken dollar as the second array. Okay. Similarly, now what we have to do is we have to check for hashtags as well. So percentage is done. Right. So percentage will be in the place according to this list. After percentage, what is there? You can see at the rate is there. So this entire order gets of the nuts array gets changed, and it will follow the order which is specified over here. So it's like somebody telling me that I have a telephone book with n numbers, registration numbers, address of the people. Now I'm going to sort the array in particular sequence based on the city location. Similarly, we will use a quick sort technique for doing this, and the quick sort technique is the most efficient way in order to do this. So this is for the nuts. Similarly, a same array is there. Output will be generated for the bolts. Okay, for the bolts. Now, how we are going to implement the quick sort algorithm? Okay, and how we are going to do this? So in the algorithm, what we are basically going to do is we are going to understand quick sort. So I will, after this video, like after this explanation, I will going to show you how quick sort actually works. It has a lot of number of steps, but you will be able to visualize it. So let's take the algorithm of the quick sort. So first we have to find is we have to match the pairs. So we will make a function match pairs over here. In the match pairs, we will pass a value n. We will pass the nuts array. What we else is going to pass? We are also going to pass the bots or the bolts array. So we are going to pass the bolts array. Then we are going to call the function which we are going to make later on, quick sort. And in the quick sort, we are going to pass nuts, bolts, the starting index and the ending index. Okay. So this is going to be our match pair function. This is step number one. So quick sort, we have called quick sort, but did we make quick sort? No, we didn't make quick sort yet. So we have to make a quick sort function over here as well, right? So in quick sort, basically we are going to make a quick sort function. In the quick sort function, I am going to pass the nuts array. Similarly, in the quick sort function, what else I'm going to pass? The bolts array. After that, I'm going to pass a low or the start index and a high index. Say high. Okay. So in this, what I'm going to basically do is I am going to first check whether the low is lesser than high. If this condition satisfies, then we are going to assign a pivot index. Pivot index, or is the pivot, like is the middle value. So I can write it over here. Pivot index, we are going to take a pivot index which will call the function partition to partition the array. So partition is again a function which we are going to make. So in the partition, we are going to pass the bolts, we are going to pass low, we also are going to pass high, nuts of low. Okay. After that, we are going to recursively call the partition function again, but this time the parameters are going to be different. Similarly, partition we are going to do for this is going to be for, say, pivot index of -1. Similarly, we are going to do partition for pivot index of +1. Okay. Once this is done, our step 3 will be to make this partition function. So how we are going to make a partition function over here? So first, for that, we are going to make a partition function which returns a value. So say for example, I can take this as int partition. Okay. In the partition, I'm going to pass a character array. What else I'm going to pass? I'm going to pass low, high, and a pivot version. So char pivot. Okay. So once the partition is done, what I'm going to do is char pivot and all those things. I am going to first assign my loop counter as low. I'm going to start from low. Then I'm going to define a loop where the starting position equals to low, and that loop basically runs towards the higher value and ++. These are all index. Okay. So first my question will be, if my partition lies in the direction which is on the left side, or which is lesser than the pivot point. So how can I define? So I can take the ARR of j if it is lesser than pivot point. What I can process and think is, see here now, this lies on the left side, right? So what I can do is, we are going to swap the values. This is how partition, or this is how the entire quicksort algorithm works. So don't get confused. We will have the algorithm at the end of this video. So we are going to take the swapping values and j, and after that we are going to increase the loop counter over here. Similarly, once this swapping is done, we can also write an else if part, which will have the ARR of j equals to pivot. Okay, then we can do is swap ARR of j and high. Okay, and similarly minus. So it is basically telling that if the element found is lying on the pivot point. Okay, so if the else if condition is also done, in the else you can write just simply swap and return the final value. So for that I can write and return I. So partition is basically giving me an index I. Okay, so you can see how many steps we have done. We have done 3 steps. Now we are left with the last and the final step, which is swapping. Because you will ask me, why we have to use swapping? Because over here you have used the swap function. So over here I'm going to define a void swap. In the void swap, what I'm going to take? I'm going to take the character array. I'm going to take the index I and j. So swapping is very easy. I think most of you will enjoy this part more than anything else. So I'm going to take sorry, I can't take temp. So I can take char temp, temporary variable, equals to array of I. Then we can assign array of I equals to array of j. Similarly, the array of j will finally become the temp. Okay, then we can close the function, and after that there will be a, say in the 5th point, which is not required for this video, we can make a main method to analyze. So this was all about the explanation for understanding of the entire quicksort algorithm, okay, and how this particular problem statement can be dealt with. Okay, so if you have any problem with the handwriting, please ignore it. And now we are going to understand how the quicksort algorithm works with a quick live demonstration of a video. So over here, say for example, this is a quicksort visualization. You can easily do it. I take 3 values, say 5. I take 5 values, 5, 2, 1, say 7, 3. Okay. Yeah. Now I press run. So you can see there are 40 total steps which are taken by this algorithm in order to show and demonstrate the quicksort. So here is the visualization: 5, 2, 1, 7, and 3. So first is select the pivot. So you can see that they have selected a pivot which is 1, okay, which is the middle value. You can see they have selected a pivot point 5, 2, 1, 7, and 3. Next we have to move the pivot which was 1. So 1 goes to the end. Okay, so the 1 goes to the end over here. Okay. Next what we are going to do is we are going to partition the subarray. So the partition of the subarray starts from 5 and 7. So after that, move the left bound to the right, until it reaches a greater value than or equal to the pivot. Okay. So 5, 2, 3, 7, 1. So the 3 will come before 7, and like this it will move. Now this is as far as we go this round. So the statement becomes 5, 2. Again 3 will come from, so 3, 7, 1. Okay. Move the right bound to the left, until it crosses the left bound, found a value less than the pivot. Okay. So you can see step left, 5, 2, 3, 7, 1, step left. Okay. We can see again we are turning over here, step left. Okay. Bounds have crossed. So 5, 2, 3, 7, 1. This is after 11 steps we are reaching over here. Now when the right bound crosses the left bound, all elements to the left of the bounds are lesser than the pivot, and all elements to the right are greater than or equals to the pivot. Okay. So you can see you are over here 5, 2, 3, 7, 1. Okay. Move the pivot to its final location. So if you see, initially your pivot was over here 1. Now we have to move the pivot to the final location, which is over here, which is because it comes under all these values, and this pivot will move to the end. So it becomes 1, 2, 3, 7, 5. Call the quicksort. Now we have to call the quicksort. You remember we have created the function on the right sublist. So the right sublist, now you have to exclude that 1 because 1 is already sorted now. 2, 3, 7 and 5 is what we have to deal with. So we have to call, again we have to select a pivot among 2, 3, 7 and 5. We have to send the pivot to the last. You can see they have sent the pivot to the last. After that we have to partition the array from 2 and 7. We have to partition it, we have to partition it. Similarly, you can see all the steps have crossed, and now we have to move the pivot to the original position. Now you can see they are doing swapping. They are doing swapping. Okay, you can see they have done swapping. Next, what left sublist contains a single elements, which means it is sorted. So when you are considering with 3 on, we have to take the pivot as a position, and to the left of the 3 there is 2. So only one element is there. That means it is sorted. The rest पीछे वाले elements you don't have to see, and the right side you have to see. Okay. Now we have to again call the quick sort function. Okay. We have to select the pivot, new pivot as 7. We have to end it to the 7. 7 goes to the 5. Okay. Partition the sub array. Similarly, move the sub arrays step right, step right. You can see all the bounds have crossed and the pivot is moved to its final location. And similarly, you can see only one element is there, which is 5 in front of this pivot. That means the total array is sorted. So in 40 steps, they have done the sorting of this quick sort. So quick sort is basically working on the visualization. I have shown you how this quick sort is working. This works on the principle of recursion and also uses swapping as one of its techniques. So now we are going to quickly solve the nuts and bolts problem. Okay. So before solving that, we are given a function match. So we will quickly call the quick sort over here. In the quick sort, what we are going to pass is the nuts, the bolts, 0, 0 and -1. You can check the dry run of the code which I've done in my in the explanation part in the video. So you can call the quick sort. You can write the quick sort function. So I will write it as void quick sort. Over here I'm going to pass the arrays. So character of nuts I'm going to pass. After that I'm going to pass the bolts array. So character of bolts I'm going to pass. After that I'm going to pass the low index. I'm going to pass the high index. Okay. So if low and high are passed, next task of mine today will be I'm going to check whether low is lesser than high. Okay. So my pivot index. So I'm going to take a pivot index, right? So for the pivot index, what I can basically do is I'm going to take the pivot index like this. That I will take int pivot index equals to partition function I have to call. So I'm going to pass the bolts array. I'm going to pass the low, high and nuts of the index low. Okay. Once the partition is done, we are going to call the partition function recursively. Partition nuts, low, high, bolts of pivot index. Similarly, I'm going to call this function again 2 times. So in this particular partition, what you can see is first I've called the no, I'm not going to call the partition 2 times. I will call the quick sort. So quick sort. In quick sort, I will pass nuts, bolts, low, pivot index -1. Recursively we have to again call the quick sort and nuts, bolts, pivot index +1, and we have to pass the higher element. So you can see that I have completed the quick sort function. Next I have to go for the partition function. So int partition character array int low, int high. Okay. Then we have to take a character pivot for this. So we are taking character pivot. We have taken lows, highs values. Okay. And what we can do next in the partition is first we are going to assign an I equals to low. So the pointer starts from low. Next we are going to traverse the loop from int j equals to low, j less than high, and j plus plus. So if in this particular element what we can see is the array of j, if it is lying on the pivot position, we can, lesser than the pivot, the left side of the pivot position, we can swap it by calling the swapping function. Swap the array I and j. Else if means that particular j position value is present at the pivot location. Just the same of the visualization I just showed you like a couple of minutes back. So we are going to call the swap function again. Swap, we are going to swap array j, and we are going to call a high value. Okay. Once the swapping is done, our next task is to close the loop. Okay. We have to come out of the loop, and then for the else part, we are going to swap array and I return it to its final value. So return I. This is the partition index it is returning. Once it is returning, we are going to call void swap. So void swap will have a character array int I, int j. In the void swap, I've already told you. So we are going to take a character temporary variable. So in the swap position, we'll take first I, then array of I becomes array of j, then the array of j becomes temporary variable. So let's compile this program. So variable declaration not allowed here. Okay, so we are taking int pivot index equals to so we have to also check what we have missed. So for this particular function, we are taking if condition. Okay, and we have to compile it again. Oops, there is a output difference. So I have to be careful and see what's the output difference. Maybe some implementation logic error. I have to quickly fix it. Your output is okay. So let's check. So first I have taken nuts, bolts, 0 and -1. Okay, done. 0 and -1 done. I'm going to take a void quicksort. I'm going to take void character nuts. I've taken bolts. Int low and high index I've taken. If the low is lesser than high, pivot index is a partition of bolts, low, high, nuts of low. Okay, we have taken partition of we are calling the pivot index. We are going to call the partition of nuts, low, high. We have done. Okay, nuts, low, and high. We have done. Then we have taken bolts of the pivot index. We have also done that. We have done quick sort of nuts, bolts, low, pivot index -1. We have done. Okay. Then we have also taken pivot index +1 and high, a quick sort. Now let's visualize on the partition array. So we have taken int partition character, okay, low array. We have taken low, high, and pivot point, char pivot. So partition of pivot. So int I equals to low. We have taken for j equals to low, j less than high. Okay, if the array of j is lesser than the pivot point, okay, we are going to swap. Okay, so we are not moving ahead in the list, so we have to move ahead by swapping. So over here there will be a little I plus plus over here, and similarly j minus minus. Okay, after that swap of we have done array of I. Let's compile. So we have compiled this particular problem. So I will just quickly tell you guys to visualize this problem statement. And it was medium based. I can also consider it as a hard problem also as well, based on the knowledge of quicksort if you have. So I would like everyone to go and check out the videos on quicksort, and you can refer to Java Pointer also for quicksort. So we are looking forward to see you on the next video. Thank you.